All right, today is October 12th. This is for my B-Day students, but my A-Day students can use this too if you're a little ahead. This is just extra that A-Day students don't have to do, but it would be a good thing if you are ahead. All right, so we're going to look at the starter that I did today. And it asks us to multiply using a multiplication table. So the first thing we need to remember is when we have a multiplication and we want to use the table, we're going to look at that subtracting 6 as being m plus negative 6. And then we're going to build our table. I'm just going to do it over here. We've got our m and our negative 6, our m and our plus 6. And we are going to find the product of m and m. M times m is m squared. It's just a multiplication table. So m times m is m squared. Negative 6 times m, or m times negative 6, but we'll put the negative 6 in the front. M times 6, or 6 times m. Again, we're putting the coefficient in front, the number that we're multiplying with in front. 6 times negative 6 is negative 36. And so our product is m squared plus negative 6m, which we'll just write as subtracting 6m, plus 6m, and plus negative 36. Now notice what we've done is we've taken the m times the m times the 6, and we've also done the negative 6 times the m and the negative 6 times the 6. So we've done the distributive property, we've just organized it all into a table form. Now I want you to notice that these two terms are like each other, and we can combine them, combine like terms. Negative 6m plus 6m is 0, so that is our answer, m squared minus 36. Second one, again, I'm going to do the table. We're going to do x and negative 5. We're going to do x and negative 11. And we're going to do multiplication of each of these. The x times the x creates the x squared. The x times the negative 5. The x up here times the negative 11 over here. So x times negative 11. And then negative 5 times negative 11. And then we add them all up. So we have x squared plus negative 5x plus negative 11x plus 55. Again, notice the two that are going together are right here. They are like terms. Negative 5 and negative 11 add up to negative 16. And we have our answer. That's how the table method works. Now, we are going to use this table method to help us with factoring. So here we go. Some reminders about factoring. When we are factoring, we should always, when you're factoring, always look for the GCF first. So I'm going to do these two examples, and example 1, there's a 1 in front here. There's a GCF of 1, so we don't have to factor out a GCF. What we're going to do, I'm going to show you how to do the table on this. So remember from section 2.5 notes that I need two numbers whose product is negative 40 and whose sum is positive 3. So I'm going to take that negative 40 two integers that multiply to create negative 40. So one of them is going to have to be negative and one of them is positive. So if I do negative 1 and 40, that sum is way off. That's 39. I could do negative 2 and positive 20. That sum is 18. Negative 2 plus 20 is 18. Negative 3 doesn't divide into 40. 4 does. Negative 4 and 10, that sum is 6. 5 divides into 40. We do a negative 5 and a positive 8. That adds up to 3. There we go. We got it. All right. So what we're really doing here is we're taking the 3k and we're going to write it as 8k plus negative 5k. And I'm going to build a table and show you how it works to do a table method for factoring. So when we build the table, when we're factoring a trinomial of the form x squared plus bx plus c, we put the x squared, or in this case, a k squared, in the upper left corner. We put the constant term, which is our negative 40. The constant is the term that doesn't involve a variable. He goes in the lower right-hand corner. And then I'm going to take my negative 5k and my 8k, and they're the ones that add up to the 3k. Now, we find the GCF of each row and column. So I'm going to look at each row and each column and find the GCF of each of those. So the GCF of each row and column and I'm going to write those right outside. So I'm going to switch colors again. Go back. So for the top row, the GCF of k squared and negative 5k, that's a k. For the second row, 8k and negative 40, that GCF is 8. The first column, GCF is k. Second column, 5, but I'm going to take the negative with it. So if the top number in your column, or the first, I should say top term, the top term in your column has a negative, or if the first term in your row has a negative, you're going to take that negative out with your GCF. So that actually gives us our factorization. We've got k minus 5 times k plus 8. And you can check that answer by multiplying it back together. You should get k squared plus 3k minus 40. We can see it in the table that it works. Okay, example 2. We are going to notice that we have a GCF of 5. 5, 20, and 20, they're all divisible by 5. So we're going to take that GCF, we're going to pull it out as a factor. So dividing out a 5, we have an m squared. Dividing the 20m by 5, we get 4m, because this is 5 times 4 times m. So we're pulling out or dividing out the 5, that leaves a 4m. And since this 20 is 5 times 4, it's going to be a plus 4. Now I'm again going to do a table for this. I need two numbers that multiply to create 4. I need them to multiply to create 4, and I need them to add up to 4. So product, two numbers whose product is 4 and whose sum is also 4. Well, the more you practice with these, the easier they'll get. It's going to be 2 and 2, and they both need to be positive because this is a positive 4. So 2 and 2 have the right sum. 1 and 4 would not, because they'd add up to 5. So building the table, we're going to put our m squared right here. Not a 5m squared, but an m squared, because we've factored out the 5. We're now working on this trinomial right here. Okay. So there's our m squared. We're going to put our constant term in the lower corner. That's our 4. And then the 4m, we're going to make it 2m and 2m. And we're going to look at each row and each column and find the GCF. GCF of the top row is m. GCF of the bottom row is 2. GCF of the first column is m. GCF of the second column is 2. So what that means is my polynomial factors as 5 times m plus 2 times m plus 2. Factors are right here. M plus 2 and m plus 2. But I want to remind you that when we multiply something by itself, that's the same as doing m plus 2 squared. So another way of writing my answer would be 5 times m plus 2 squared. Kind of like that one, but you could leave it this way as well. Step up above. All right, we have one more example from here, and then there's a worksheet out there on Canvas that I'm going to do the odd numbered problems for. All right, so example 3. We're going to take this little technique right here and make sure we understand what I'm asking or what I'm saying to you here. So if you have a negative leading coefficient, you're going to factor out a negative. Whether your GCF is 1 or whether it's something other than 1, you're going to factor out a negative. So for the example that we have 3 terms, t to the third, 7t squared, and 6t. They're actually negative. That leading coefficient is negative. A couple of them are negative. Leading coefficient is negative, so we're going to factor out a negative. The GCF is t, but we're going to factor out a negative t. So we're going to factor out a negative t. So take out a negative t. Think about it. Negative divided by negative is going to be positive. So we're taking the negative out and we're taking a t out. We're going to have a t squared left. We're taking a negative and a t. We're taking out a negative and a t. Look at what happens. We get t squared, because negative divided by negative is positive. T to the third divided by t is t squared. The 7 divided by negative 1 is negative 7, and t squared divided by t is t. So notice the sign switched because we took out a negative and we took out one of the t's, so we now have t to the first power inside the parentheses right here. Okay, and then last one, negative divided by negative is positive, and the t is being divided out, so we have a 6 left. Now, what we're going to do is we're going to try to factor the t squared minus 7t plus 6. So remember what we need. We need two numbers whose product is 6, and I have to have a sum of negative 7. All right, so I need a sum of negative 7 is what I'm looking for. So I could do, they both have to be negative, don't they? Because they're going to add up to negative 7 and have a product that's positive, they both have to be negative. All right, so negative 1 and negative 6. Yep, that'll work because that's a sum of negative 7. We got it first time. See the negative 2 and the negative 3? I don't have to worry about them. Their sum is negative 5. Negative 1 and negative 6 are it. I'm going to build my table. We're factoring t squared minus 7t plus 6. So we're taking the negative 7t and we're writing it as negative 1t plus negative 6t. Then we're going to factor out the GCF from the top row. From the bottom row, factor out that negative with that 6. And then we're going to factor the first column. First column has a GCF of t. Second column has a GCF of 1, but we're taking the negative out. So we'll have a negative 1. And that is our factorization, t minus 1, t minus 6. Right? And that's that example. All right, so now I'm going to dive into the odd numbered problems in the worksheet. And you can feel free to just stop right here and just do the problems on your own and just use the video to check answers. Oh, wait, I had one more thing I need to talk about. Just kidding about that. So factoring a difference of squares. a squared minus b squared equals a plus b times a minus b. Something we have not talked about yet, but it's super useful. Where does that formula come from? Well, a times a is a squared. There's a negative ab. There's a plus ab. And there's a minus b squared. These two, whoops, I said mine plus ab, and then I forgot to write the b. So a squared minus ab plus ab minus b squared. These two add up to 0, so what I'm looking at is a squared minus b squared. This is what we call a difference of squares because we have a difference and we have squares. So difference of squares, kind of like Mickey Mouse ears there, huh? All right, so difference and squares, difference of squares, but we can always factor a difference of squares. All right, so what I'm going to look at is I'm going to look at this example 4. I need to recognize that 100 is 10 times 10, or 10 squared. So this is in the form a squared minus b squared, where a is, whoa, rewind. My brain was getting ahead of my something. My pencil was getting ahead of my brain something. This is in the form a squared minus b squared, where a is p, look at the matchup, and b is 10. So I'm going to factor that as a plus b, p plus 10, a minus b is p minus 10. And it works. Okay. We could also look at this as being p squared plus 0p minus 100 and ask ourselves what two numbers multiply to create negative 100 and add up to 0. That would be 10 minus 10. And it works that way as well. Okay, I think I'm going to stop right here and make a separate video for the odd number problems on the worksheet.